Here we go with sorting algorithm tracing worksheet number 1. If you're given these values right here in this fictitious array, where 80 is in index position 0, 50 is in index position 1, etc. In the first pass of the outer loop in your selection sort, the algorithm goes from left to right and scans and finds 10 to be the smallest element. And if your goal is to sort in ascending order, that is from low to high, that 10 swaps with the 80. So you can see that I rewrote that on the second line here. Everything else, the 50, the 60, the 45, and the 75, they all remained in place in their respective index positions of the array. Then on the second pass of the outer for loop, the algorithm only checks from the 50 through the rest of the array, and it finds that the 45 is the smallest of those elements. So the 45 swaps with the 50, and we rewrite the array with now the 45 in its final resting place. Now the algorithm, on the third pass of the outer loop, it checks the remaining elements, and the 50 is the smallest. So that 50 and the 60 swap. And we now check the 60, 80, 75. The 60 is the smallest, so it is selected and it stays where it belongs. Everything else here to the left stays in the same positions, and we would just rewrite the rest of that array as 80, 75. So there wasn't much action between that pass of the outer loop and this pass of the outer loop. In fact, the 60 swapped with itself. But now you would underline the 60 to show that it's in its final resting place. Finally, the last two elements here are checked, and the 75 is selected, and it swaps with, well, the 80, and it's in place. And typically the selection sort is written in at least a reasonably efficient way, that it does not check again with another pass of the loop to be sure that the 80 is in its final resting place, because since it's the only element left, it's there. So that's the end. You had to fill in on this worksheet that one line of numbers. Now let's execute this one. If we proceed this far down with these two elements in their final resting places, we are now selecting the smallest number in this batch of 4. It's 34. So the 34 swaps with the 75. Everything else stays where it belongs, where it currently is. 20 and 25, that's for sure, they stay the same. The 50 and the 88 haven't been selected yet. So my style is to underline all three of those elements, including the 34 now. On the next pass of the outer for loop, the algorithm compares the 50, the 88, and the 75. The 50 is the smallest, so the 50 is now underlined, it's now set in stone, and these other elements, of course, are still where they originally were located, and the 88 and the 75 stay in the same place. So the 50 was selected as the smallest element, and it now is in its final resting place. On this last iteration, I've already filled in the answers. Of the 88 and the 75 is the smallest, so it swaps with that 88, and we're finished with that exercise. Okay, let's do this one by ourselves. We first scan from left to right, and we find that the 40 is the smallest. So the 40 swaps with the 90. And everything else comes along for the ride. They all stay in the same respective positions. And doing this the way I do it, I underline the 40. Now the algorithm checks this latter portion of the array, finds that the 50 is the smallest. It swaps with that 80 to its final resting place, and everything else moves forward where it belongs, where they originally are. Now the algorithm That's a 40 there, by the way. Now the algorithm compares these items. It finds the 60 to be smallest, so the 60 swaps with the 70, and it is in its final resting place. Everything else comes along for the ride. In the next outer for loop iteration, the 70 is the smallest, so it stays where it is. There is no swap that executes in this iteration, but we do have to show this as a step in our exercise here on this worksheet. And on the next loop iteration, 80 and 90, they're compared, and the 80 is determined to be the smallest, so it's placed there, and everything else comes along for the ride. And finally, while we're finished, the algorithm doesn't go any further because the 90 is the only element left that hasn't been searched, and it hasn't been selected yet, so it just stays right there. Okay, that's the selection sort. Now let's do some exercises with the famous insertion sort algorithm. We have one missing row to fill in here. Let me check this out. Let's see, the 80 is currently sort of in your poker hand, and the 50 is compared with the 80, and the 50 is inserted into the to the left of the 80. That shifts the 80 to the right, and so now your fanned out poker hand cards are 50 and 80. The dealer deals you a 60. The 60 is compared with the 80. It's less than that. The 60 is compared with the 50. It's greater than that. So the 60 needs to be inserted in between those two elements. The 80 shifts right. The 60 plops in there in between, and the 50 stays where it was. And that's what happens on that outer loop iteration. The 45, the 10, and the 75 haven't been involved yet. They're still sort of like face cards that are, or playing cards that are face down in the dealer's hand. They haven't been dealt yet. But continuing just to see what happens, this 45 is now checked against these three cards. 45 is less than the 80, it's less than the 60, it's less than the 50. So the 45 needs to be inserted there. It is. And everything else shifts to the right. And now we've successfully sorted these four cards in our poker hand. The 10 gets inserted to the left of the 45, shifting all four of these numbers here to the right. And now that's where it belongs, the 10. The 75 needs to be inserted in between the 60 and the 80. So that shifts the 80 to the right, and that's where the 75 belongs. We are now sorted from low to high, which was the goal. Okay, it looks like we have a couple more passes here of this outer loop. The 20 is in place, the 20 and the 50 are in place, the 20, 50, and 75 are in place as of that iteration, and so on. Now the 88 is compared with the 75, and it's not less than that. So the 88 is inserted right where it currently is. There isn't much action there, there's no shift, and that's just how we would rewrite that step. The 34 is still in the possession of the dealer, and now we do one more outer loop pass or iteration. The 34, it's compared with the 88, it's less than that. It's compared with 75, it's less. It's less than the 50, but it's greater than the 25. So the 34 never gets compared directly against the 20. The 25 sort of blocked it, and the 34 needs to be inserted in here in between the 25 and the 50. All three of these guys need to be shifted to the right in this array to make room for the 34 that needs to be plopped in right here, and the 20 and the 25 stay where they originally started. So we are now sorted, and this is the answer for this exercise in the worksheet. Let's do one more. Number 6. Whoa, look, everything's in reverse order. Potentially, we have a lot of work to do here. Well, we start with the 90. Okay, that's nice. We have the 90 in its proper place. Now the 80. The 80 needs to be inserted to the left of the 90. So we have 80 and 90. Everything else just sort of dittos. I'm just going to use ditto marks or arrows there. Now the 70 gets compared against these guys. They shift right to make room for the 70. And the 60 and the 50, ditto, 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 they're still there. I'm being lazy here, and you can write these out on your own worksheet. The 60 is now compared with the 90. It's less than 80, it's less than the 70, so it comes right there. Everything else shifts to the right. We still have this 50 here. We still have this 40 here. And we're sort of sorted up to that spot in the array. And the 50 now is compared. It needs to be inserted to the tail end here, or the beginning end, I guess you would say. And the 80, 90, and all that shifts to the right. And finally, the same with the 40. The 40 needs to be, it's less than that, it's less than that, it's less than that, so on. It gets inserted down here, and everything else gets shifted to the right. And we are finished with this exercise and this whole worksheet, focusing on the insertion sort algorithm and the selection sort algorithm, and how numbers in an array or an array list would be swapped, or in the case of the insertion sort, be shifted and inserted to successfully be sorted.